My name is Chris Helma, and I'm a senior engineer at AWS. Been working with Andy for the last 6 months on a cool new project to make it easier to do Arkime packet capture in a cloud-native manner in AWS. You know, it's kind of tempting, sort of just port a on-prem approach to the cloud, and that's usually not sort of how AWS is best utilized. So we really wanted to make it easier for people to have an Arkime solution that's not just a way to sort of quickly deploy this stuff, but to create it, to manage it, to tear it down, and follow all the AWS best practices so that you don't have to figure it out from first principles. In general, just make it easy as possible to use it as a full-fledged solution. So that's what I'll be talking about today. And the project is in GitHub. Let me share my screen. Project is in GitHub in the Arkime repo, and lots of information in the README about kind of what this project is, how to use it, and so on. Maybe we can start off with a sort of walk through the architecture. So at the end of the day, you have this account on the left-hand side, this user traffic account, and there's an existing VPC, and it contains maybe some EC2 instances, maybe some ECS Fargate, and you want to capture the traffic that's going to and from those. So the way to do that is to use this tool that's Arkime AWS all-in-one tool, which is a command line interface written in Python. You can see down here, this purple box. And an operator will go ahead and interact with this in order to create an Arkime installation, manage it, change it up, change configuration, and so on. So the number of operations you perform, the first one is typically going to be cluster create, and that's going to create the core components of the Arkime installation, which is all the stuff on the right-hand side. So the green stuff is kind of the capture components, and the blue stuff is kind of the viewer components. And in this particular scenario, we had a user who had a corporate network, which is a particular IP space, and they had to have their viewer match that up in order to be able to hit the viewer's load balancers. So that's why there's two VPCs for capture and viewer, but it's a very configurable situation or setup, so you can have a single VPC. But at a high level, you have the capture VPC, which contains ECS on EC2 capture nodes, and they feed the metadata to OpenSearch and then raw data to the PCAP bucket. That's 3. The viewer lives in a VPC. Maybe it's the same VPC as the capture. Maybe it's not, depending on your settings. And it's just Fargate, also Dockerized, containers behind the load balancer. And the analyst will hit the load balancer to hit the viewers and get the data from the OpenSearch domain in the PCAP bucket. And that's kind of what you get when you call cluster create. And then, after you call cluster create, you're not actually capturing any traffic. You have to call a command to register this VPC as something you should add to your capture portfolio, and that's what VPC add will do. And VPC add will go ahead and create all this red stuff, which is sort of stuff that will be installed in this account in the VPC in order to mirror traffic to the gateway load balancer on the capture cluster. And there's a number of sort of cool things here. So we use a product called VPC traffic mirroring to make this happen. And by default, VPC traffic mirroring has to be manually configured on a per interface basis. So every EC2 instance, every Fargate, every ECS container has a network interface. And because it has to be manually configured, it's kind of a pain in the butt to do. But we've set it up so that the entire system is event-based. And so the stuff we install on the account is constantly watching for new instances being spun up or new instances being torn down. And we'll emit an event that goes to a Lambda function that will go ahead and do all the mirroring setup and tear down for you, which basically means that you don't have to worry about your fleet scaling and then not getting traffic captured correctly. So that is sort of a high-level view of what this is. Next, let's spend some time looking at the actual interface that the user has. So this is my Mac. It's a terminal session. I have checked out the repo locally, and we have the CLI set up and ready to go. So it's a Python CLI that wraps a library called the Cloud Development Kit, which is used to do all of the AWS resource creation and modification, updates, destroys, that sort of stuff. But we mentioned the cluster create command. That's one of the options that's pretty prominent here. Mentioned VPC add, another really important command for sort of setup initially. We also have things like the clusters list command that'll tell you all the clusters, the Arkime clusters that are set up in your account. We have a command that'll allow you to change the Arkime configuration based on stuff that's on your laptop or whatever you're running this off of. There's a command for getting the login details of the viewer. So like the DNS name and then the password and so on. And of course, there's the teardown commands, VPC remove and cluster destroy. So when you call a cluster create, there's quite a few options for configuration. And the idea is that you're able to specify sort of the parameters of the capture, right? How much traffic roughly you're expecting to need to store, how long you want to retain the session information, how long you want to retain the raw packets, how many replicas to keep, and so on. And you can also specify like the CIDRs for the cluster, for the capture and viewer sides of things, if they need them to have specific IP addresses to play with your corporate network, for example. But we take all this information and we use it to figure out how much capacity to provision, so we don't like way under provision or way over provision capacity for you in your Arkime cluster. And additionally, when you call cluster create, before we actually provision anything, we'll give you an idea of kind of what we would provision with your settings that you specified. So this is just sort of the default settings. So they give you like a very high level price estimate based on US East 1 pricing, on demand, and so on. As everyone knows, pricing for AWS is very highly variable based on discounts, region, usage, everything else you use in the account. So, but this is just kind of a ballpark, It'll also tell you roughly what we're going to provision. Actually, not roughly, exactly what we're going to provision in terms of resources. So it'll tell you how many capture nodes, what size the EC2 instances are, how big the OpenSearch domain is, and what its parameters are, and so on. So that allows you to get a sense of whether you actually want to go through with this particular operation or not before you commit to it. But if I hit yes, it would go ahead and deploy them. But that takes a while, so I'm going to abort. Instead, I have a existing Arkime cluster set up already, and I ran the clusters list command to get the information for it. Most of this is sort of version information, but you can also figure out kind of the name of the cluster, which is my cluster, and the domain. But probably most interestingly is the VPCs we're currently capturing the traffic in. And this particular VPC is in a different AWS account than the cluster itself, but you can see the account ID and then the VPC. So what we're going to do is we're going to add a new VPC to this cluster as part of the demo. So let's go ahead and kick that off. So this is a VPC that I've already created. Both this VPC and the one that we're already capturing just contain Docker containers that are curling like the top 100 sites, just to provide some dummy traffic for the purposes of a demo. And we see a little bit about kind of what this is doing. I mentioned this is a Python CLI, so the first stuff is orchestration on the Python side, and then it passes over to the Cloud Development Kit. The Cloud Development Kit is a TypeScript library and command line tool that allows you to basically define CloudFormation agglomerations in TypeScript, and it'll basically translate the TypeScript into JSON for you. And it's pretty sophisticated, but it makes it a lot easier to do infrastructure as code using CloudFormation. So we basically wrap that in our Python and tell it to go ahead and deploy this stuff in our account for us as part of VPC add. So, I have this account already. Let's go ahead and take a look at the viewer. I would normally run the get login details command to get the details, but I don't want to do that on a recorded call. So I just have it here in my browser. And let's go ahead and actually do this. So right now I have it configured using the default Arkime user configuration. There's an admin user and there's a password you can log in with. So let me go ahead and enter that real quick. And when you call it create cluster, it'll go ahead and create the admin user and the password and all that sort of stuff securely for you. It sticks the password in secrets manager, so it's the Amazon way. We see in our dashboard we have the curl traffic. We're getting like between 200 and 300 sessions per time increment right now. Let's go ahead and show off the ability to scale up our capture rapidly. I think that's a key feature, is being able to reactively add mirroring sessions. So this is the AWS account that contains that first VPC that we started off with already configured to capture. And in it is a Fargate cluster. And the Fargate cluster is the one that has the Docker container that's just curling Alexa top 100 sites. Right now it has a single task that's doing that, but let's just add some zeros to that. Make it 100. And I'll give it a little bit of time, and it will, our Arkime system will automatically detect the new traffic sources and start capturing the traffic. But while we're waiting for that, let's take a look back at the VPC add command. Okay. So there's a lot of stuff going on behind the scenes while this is sort of sitting here. And by default, we don't show too much information in standard out, but the full details are sent to this Arkime, manage Arkime log, which I typically have tailed in a separate terminal window. In this case, I'm using tmux to have multiple terminal sessions going. So I'm just switched to the log tail, and you can sort of see what's going on. At this point, we're doing CloudFormation updates or deployments of the stuff to make that that new VPC we said to add to our capture portfolio created. Looks like it's getting pretty close. We'll see. It takes about 4 minutes or so to add one of these things. Oh, there we go. Cool. So yeah, notice that we have these messages saying that we're initiating creation of mirroring sessions. If we go back to the diagram, we have this event bridge bus, which are listening to events. And by default, in your AWS account, whenever you get a new EC2 instance or container created, it emits an event which goes to this bus that we're listening to. So we just sort of leverage the same bus to do the initial creation of the initial mirroring setups is that we're using sort of to detect any changes afterwards. But it sort of demonstrates that we start out Python, we move to CDK, and then we end Python. So hopefully we'll be able to see the new traffic from that huge amount of instances that we just added to our fleet. There we go. So now we're getting like 3,000 instead of about 250 or something like that. I think this goes up to about 9,000. If you'll give it a couple seconds, but it didn't change anything other than basically tell Fargate to spin up more instances, and the AWS all-in-one solution automatically created all the mirroring components so that you don't have to manage them, which would be quite a hassle to do by hand. Actually, basically, effectively impossible in a real operational scenario. So it's a pretty big win to be able to have that happen automatically. So the next thing I want to show off is sort of how you would change configuration. So we have these ECS on EC2 and Fargate backed Docker containers. One set of them contains the capture nodes running the capture Arkime process, and one of them contains the viewer process. And by default, when you call create cluster, we just sort of use a default configuration. And we'll put this configuration on a location on disk and the directory of the repo on that you checked it out, right? And it's not intended to be like what you use in production. It's just something that works automatically. It just goes, right? So the idea has always been that you would sort of tweak this, right? As a practical example, we're using the default auth mechanism for Arkime, which is probably not the best choice for a production environment. So let's turn on single sign-on as a practical example of how you'd sort of change this configuration. And in our scenario, we have created a Cognito user pool, which is going to interface with the Amazon single sign-on. And what we need to do is just tell the Arkime viewer, hey, we're going to use this single sign-on thing for OIDC. So I'm going to VS Code, and kind of hard to see, but I'm in the AWS all-in-one directory, repo directory, and in it I have this directory called config my cluster account number, region, whatever, right? And it contains this configuration that I mentioned. By default, you end up with configuration for your capture nodes and configuration for your viewers. And then it is stuff like the Arkime configuration, which you're looking at right here. So this is the viewer's Arkime configuration. It's the standard Arkime config file. No real special stuff there. And another thing that's interesting is, we have this bash script, which is sort of an entry point. So like when you run a Docker container, there's an entry point command, and as long as the stuff that you're running is all part of that entry point command in some way, you can basically make the Docker container do anything you want to start when you start up. And that's basically what this is. This is like a way for you to customize the startup behavior of the Docker containers. Right now, it's basically just doing pulling down credentials and doing some seds to replace configuration that's static in the configuration files with stuff that's actually real values, right? So for instance, like the cluster name and the viewer DNS name and that sort of stuff, right? But you can modify this to have anything you want in here. And so the way this works is when you call a new command, config update, I guess also when you call create cluster or cluster create, we basically take this capture directory, turn it into a zip file, stick it in S3, and then as part of the capture node spin up process, we'll pull it down, unpack it, and then run this initialize Arkime script. And same with the viewer. So anything you put in these directories will end up on the Docker container, and you can add stuff or remove stuff from this initialize Arkime shell script and just have it do anything you need it to do. In our particular scenario, we're trying to turn on single sign-on. So I have the viewer's config file here, and I just need to uncomment these lines. And so it's Cognito pool and information about Cognito, whatever. And now let's go ahead and just deploy it. So go back here. We're going to call config update. And this is going to do that process of figuring out if there's a change in the configuration in those two directories, turning into a zip file, putting it in S3, and then bouncing the, the viewer or the capture ECS services as appropriate. In this case, it didn't need to bounce the capture stuff because nothing had changed on the capture side, but it saw that there was a change in the viewer side, so it's bouncing the viewer ECS service. And if anything goes wrong, we basically look for failed container starts, and we'll roll back to the previous configuration automatically. We also roll back if you like Control C accidentally, so you don't have to worry about a bad update putting you in a situation where it's impossible to recover from. And it's always a little bit of a gamble how long this actually takes for it to do the bounce. So let's go check the okay. That was pretty fast this time. So this was the previous viewer node, and we just spun up this new node right here with the new configuration. And so previously I signed on, oh, that's an interesting visual artifact. I signed on using this admin password. So hypothetically speaking, I should be able to do a full reload of the page, and it should redirect me to my company's single sign-on. We'll see what happens. I still haven't figured out quite why this happens yet. You just like have a couple seconds and reload a couple times. I think it's a side effect of how we're doing the initial user creation, because what we'll do is we'll, as part of the command for the redirect, we create the user. I think that just has to go through the first time, and then the second time you reload the page, it works. But now we're in using single sign-on with OIDC. So that was pretty painless, for OIDC, that is. It's never entirely painless. Yeah, so that's basically what we got for our demo. Love to answer questions if people have them.